we have some forwarding. So now we have lecture number 9 and then we have some forwarding here. So please remember, we have some forwarding from the ALU out 1 and ALU out 2, remember? Okay, so what we are going to do, I will explain this with an example. Okay, so please remember, so now still I will cover that okay, so this is a figure without forwarding or with forwarding? Help me. Yes. This is the figure without forwarding or with forwarding? Without forwarding. And in forwarding, so it means that there are some feedback loops. There are some feedback loop. One loop is from where? ALU out 1 to A. So now we have some A register and then we have a feedback path. Okay. One file is coming from where? From reg file, register file. One path, this is my op1. Other line is coming from where? Help me. ALU out 1. Other path is coming from where? ALU out 2. Another path is coming from where? LMD. So now there are 4 paths. Please remember. So now LMD. It is not shown here, but with forwarding, it means that there are 4 forwarding paths. And that forwarding path, this is op1, so this is mux1. So this is my mux1. Remember, this is my mux A. Clear? And then we have 0, 0, 0, 1, 1, 0, and 1, 1. If the value of the mux is 0, 0, from where it's coming? From register file. And the same thing is true for what? Mux. Any question? This is clear or not clear? So now you need to consider that. Okay, now if you look at here, again, so let's assume this address is 0x3000, this address is 03001, 0x3002, and 0x3003. Okay, and then we look at how these instructions will go through the pipeline stages. Okay, again, we are going to solve it. And since we are going to solve it, so we have then, remember, we have different stages. So we have PC, okay, and then we have NPC, and then we have IR. Clear? Then we have what? We have register A, then what? B, the temporary register A and B, and then immediate. Then what we do, we have anyone? Op1. We have op1, op2, and then ALU out 1. Yes? ALU out 1. Then we have, in the next cycle, what do we have? Help me. LMD. Then what? ALU out 2. And in the last stage?
There's B2.
Huh?
There's B2.
B1 and but because since you are not covering load, store, so I am skipping that. So you are not covering store here. Okay, so now we have, we can add more to it here. So then we have F in the line, so we have reg value and reg number. Okay, now for the first instruction it is very simple. So for the first instruction, so we have add R3, R2, R1. So basically what will be the value of PC? So now I am going to have the red color. So if you go with the red color, so this will be PC will be 0x3000. What will be NPC? Clock cycle 1. Then we have clock cycle 2. Then we have clock cycle 3. Then we have clock cycle 4. Then we have clock cycle 5. Then we have clock cycle 6. Then we have clock cycle 7. Then we have clock cycle 8. And then 9. And then 10. So we'll see how it works. So we have 0300, so the NPC will be 0x3001. IR, what will be IR? The machine code of I1 and A. If you go to the next stage, so we have R2 and R1. What is the value of R2? The value of R2 is actually 0x3FFC. And then R1, what is the value of R1? 4. Immediate will be what? Don't care. Then we proceed to the next stage. Yes? We proceed to the next stage. What will the value of op1? 3FFC, and then 4. Now we have area out 1. Now this is tricky. So if we add 3FFC plus 4, so what we are going to do, so 3, so now please remember, so we have the first instruction. So we have 3FFC plus 4. If we add it, so C plus 4, D, E, F, 0. So 0, 1, 0, 1, 0, 1, and then 4. Got it? So now we have the area out 1 will be what? Clear or not clear? Okay, now we move to the next stage. LMD. Don't give. Area out 2. 0x4000. Go to the next stage. Reg value. What will be the reg value? 4000, 0x4000, and reg number R3. So now the first instruction will be khalas in clock cycle 5. But now there is a complicated situation. Now the complicated situation is here. Now this is tricky. This is very tricky. Okay, now at this point of time, what is this register value? What is the value of this register? Help me. 3FFC belongs to which register? R2. Clear or not clear? 4 belongs to which register? Help me. R1. This value will be written into which register? R3. So now we have the value of the first register 3FFC. We are adding it with 4. The new result is now 0x400. But this value of 0x400, please remember, this 4000 is written into R3 in which clock cycle? Clock cycle 5. So now this value will be overwritten. So now what I am going to do, so this value will be overwritten in the register 5 in which clock cycle? Help me. Clock cycle 5. But now there is a problem. We need the value, updated value of R3. So do we need the old value or the new value? The new value. So we need the new value, but old value is FFF2. Okay, now the problem is that, so the new value, if it's written the new value, so the new value will be 0x4000. So please remember, this R3, so this R3 should have the updated value, and that updated value should be 0x4000. But now the problem is that we are writing this value 0x4000 in which clock cycle? Clock cycle 5. But now the problem is that we need this value here in clock cycle 3 for the second instruction. Now I will now move to the blue pen. Now I will move to the blue pen. Okay, now this is my blue pen. Okay, now again the same thing. So we go to here. So this is my 0x. What is the NPC here? Help me. 3001 NPC 3002. Then machine code of what? Right. Now the problem is that now we are in clock cycle 3. We are now in clock cycle 3. So now we want to. Okay, now please remember for this LDR instruction. So please remember. So now I'm separating it. Now what I'm going to do. So now we have this instruction. We have LDR R4 R3 hash 2. In the absence of dependencies, this value R3, in the absence of dependency, this should go where? This could go to which thing? Op 1 in the next clock cycle? Yes or no? It should go to op 1, and where this should go? Help me. Op 2. From immediate value it should go to op 2 in the next clock cycle. So what we are going to do? Okay, now please remember. Okay, now please in this case E1. If you do it here, now let's say if you consider A. Now this is A. Okay, please remember there is a path from A. So for this thing, this is mux A, and this mux A is op 1. Okay, now the problem is that now we are reading from the register file, okay, for the second instruction. So now what value will we read it here? Help me for the green one. So the old value. What is my old value now? FFF what? 2. Is the correct value or incorrect value?
Incorrect value. Okay. B will be don't care. What will be the value of immediate? Okay, so this R3, this R3. Okay, and please remember, so this R3 will go to A, and now we have the old value. And then what is the value of immediate here? Tell me.
2.
But now we have the updated value, which is 400 from here. So this should go to op1 or this should go to op1. Help me. The new one. So basically this new one should go, please here. So in this case, this will go to op1 and that value is what? Help me. 0x400. And that is ignored. I stand for ignored. In a similar way that you people ignore me during my lecture. Busy in your mobiles, maybe busy in your laptops. In a similar way. Okay, so now can you see here? This is now op1 here. Then what will be the value of op2? 2. It's coming from here, not from here. Clear? So now this will go from here. This is 2. This is called as what? Forwarding. This is called as forwarding. And please remember, this is very tricky. And since we have forwarding, okay. Now what is now the new value of op1? Can you tell me what is now the value of op1? Help me. 0x. Very good, Dalia. Very good, Dalia. And then what is the value of op2? Plus 2. What is now the new value? 0x4002. What is the effective address? That is because in LDR this is the effective address. So now it means that now we will have some value in man memory, and there will be some address. So that address will be 0x4002, and here there will be some value. Maybe that value is 6. Maybe that value is 6. Okay. Okay. Now what we do? So now we have value out 1. We add these two because now we want to calculate the effective address. 4000 plus 2. What will be the new value? Help me. And please remember, this 4002 will go where? MAR or MBR? This is the address now. MAR or MBR, how many times will I repeat? How many times will I repeat? Millions and millions of times. Okay, so now I'm saying this will go into MAR. Clear? Are we reading or are we writing? Reading. Okay, so now this will go with MAR. From MAR, this will go 6. Will go where? MBR. And from MBR, where it will go? LMD. So please remember, if in this stage I also give the addition state of MAR, so this will go to MAR, this will go to MBR, and from MBR it will go to LMD. So now what will be the value of LMD now in this case? 6. Very good. LO2. LO2. Don't care because it will not be worried. Please remember, here LO2 was used when RD was using as a register. But since we are having R4 now here, R4, okay, so R4 will be written in which clock cycle? Clock cycle 6. And what will be the value of reg value? Help me. This 6 will come here, and which register we are writing? Any question? Any question? Now we go to the next. We go to the, because why I'm explaining this? This is a little tricky. This is a little tricky, and I will generalize the rule. I will also generalize the rule. Now let's assume we proceed to the next instruction. Let's assume we proceed to the next instruction, and next instruction is now an add instruction. Okay. Now when we have an add instruction, so we have I3. What will be the value of PC here? Help me. What will be the value of PC? 003002, this will be 0x3003, and then machine code of I3. Okay, now in the next cycle, we need which register? Help me. R5. No. R5 is the destination for A. R4, what is the value of R4? A. And please remember, A. Do we need this A? No. this is actually, I said A, we should ignore it. B, what will be the value of B? Don't care. What will be the value of R3? Please remember. R3 is not even written here now. R3 is not even here. What is now the value of R3? The old value. Please remember, we have the old value of R3. FMF 2. We should also ignore it. And I'll explain it why. Okay, now in the next cycle we go to op1. Okay, now we have, let's say this is an add instruction. So now this is my add instruction now. We have R5, R4 and R3. What should be the updated value of R4? No. This should go to, remember, the updated value should be 6. Please remember, this value should be 6. What should be the updated value of R3? R3, what is the value of R3? 4000. Am I right or not? But now the problem is that we need this value, the value of 6 here. We need the value of 6 in which clock cycle? Clock cycle 5. But this available is now available in where? LMD. So now this are, yes.
Professor, why did you put FFF2 in the latest field?
Because we will consider the old value. It will be updated in the next clock cycle. This will be available. Can you see? In this case, because this is the second operand, that will consider the old value. We can also don't care it. We can don't care it. And we can say it, okay, since we do not need this value, so I can say I invalid and I invalid. Because this value will be provided by the forwarded result. The old value will be ignored. So what does I stand for? I stand for, okay, we can have a new thing. I stand for ignore the old value. Got it? Any question? Okay, now this LMD is available here. This will be available in the end of clock cycle. But we cannot read it. Since we cannot read it, so there will be what? One stall. Even with forwarding. So please remember, so now I also have a rule now. So in this case, it will be now stall here. So now we can have a stall here. Stall here, so clock cycle 5 will be stall here. And since it is a stall, so this will also be a stall. Okay, this 6 will be forwarded to where? Help me. To op1. Okay, no, so basically this will be forwarded to op1 because you know this has to be forwarded to op1. This is clear or not clear? Okay, so now we need this in op1. This and 6 will be given in op1, and this is 6 here. Now it's forwarded. What about op2?
Prof,
Yes?
why don't we forward it directly? Since we
No.
can write back.
No, but the problem is that you have to provide the MAR, and it will take some time from the memory to load the data, and it will take some time. So it will be provided in the end. Clear? So you cannot do that. We cannot do that because we cannot do the memory operation and the read-write operation at the same time. So first you have to load it in LMD. When it will be uploaded, then it will be provided in the next clock cycle.
Unlike register.
No, unlike, because this is no first half and second half. Because no, we cannot do this operation with the memory. Clear? We can do it with the register file, but not with the memory. Clear or not clear? Okay, now this is 6 now. What will be the op2 now? Help me. What will be op2? What is the next register? No, we cannot take it from LEO2. There is no need because there is also a stall here. The value of R3 is already written in the register file. Can you see it? Because of this stall, this value of R3 is, now we have an updated value from R3. So this value will go. Any question? Okay, so this value will go here. So 0x 4000, and when we add them, what will the result now? 00406. LMD in the next clock cycle because it's ignored there, and now LUO2 4006, and then this value will be written into register file. Into which register? 0x4006, and it will be written in. Any question?
Professor, I don't understand how you stop.
Because there is a reason for that.
Like, why do you start after clock cycle 4?
There is a reason for that. Because the problem is that we have a value of 6 here. We have to provide this 6 to up1 in the next clock cycle. We cannot use it in the same cycle. So this value is now in LMD. Okay, I will explain. I will explain. So should I rub this off? Because I am going to explain now what will happen. Should I rub this off? Okay. So let's assume we have two instructions, and now I am going to generalize it. Assume we have this instruction. Let's assume we have I. Any instruction I. So can I write it add? We can have not add any operation. It can be add, subtract, any operation. We have RD. And then we have RS1 and we have RS2. Clear? Okay. If you say if the first source operand, please remember the first source operand. The first source operand of RS1 is dependent on the RD, independent on the RD of I-1 and the previous instruction. Dependent on RD of previous instruction and I-1 is a load instruction. What we need to do? Introduce what? A star. We introduce a one star. Again, else if the RS1, okay, introduce a stall. RS1 is equal to RD of I-1, and it is not a load instruction, and it is not load, and I-1 is not load instruction. Then what do we need to do? Forward from where? Help me. Forward from ALU out 1. Forward from ALU out 1. Clear or not clear? Okay, again, else if RS1 is equal to RD of I-1, and I will give you some example. I-1 and I-2. So this is very clear. Forward from where? It depends on that. Forward from ALU out 2, and else it means it is depending on I-3 or blah blah blah. So then we can read from where? From register. Any question? Clear? And then I will cover some new scenario. I will explain this with some example. Clear? Should I wrap this up? So what I am going to do, so I give you a question, and then you will tell me how many clock cycles will be required to execute this sequence of operation. Okay. So please, for assumption 1 and assumption 2. So let's assume we have this instruction. Add R5, R3, R2, and add R4, R5, R1. Clear? We have two assumptions. Please remember, we have two assumptions. Assumption number one. No forwarding. Assumption number two. What is my assumption number two? Forwarding. Okay, please remember. Now what I am going to do, now I am going to have. So now I am now going with the assumption number one, which is no forwarding. So assumption one, no forwarding. So we have no forwarding. If you have no forwarding, so now I am going to do with the first instruction, so which is actually the read instruction. So the read instruction is in fetch stage, then decode stage, then execute stage, then memory stage, then what? Write back stage. So this is my I1. Now we go with which instruction? With the black instruction. Okay, with the black instruction we have no forwarding. We have fetch stage, then what? Fetch stage, then we have decode stage. But now the problem is that we need the value of R5. And R5 will be written in which clock cycle? Clock cycle 5. So how many stalls do we have? Stall, and now value is written here. Since value is written here, so basically then we have decode stage here. So it will be forwarded from the register file to here, and then we have which stage here? Help me. Execute, then what? Memory, and then what? Right back. 1, 2, 3, 4, 5, 6, 7, 8. How many clock cycles? Clear or not clear? This is okay. So think there is no forwarding. Now we have another assumption. We have forwarding here. Now we have the forwarding assumption here. If you have the forwarding assumption, so now I1 is now fetch, decode, execute, main memory, and write back. And now for the I2, if you look at I2, so we have fetch, then we have decode, then we have execute, then we have memory, and then we have write back. And now the problem is that the thing is, so when we have this execute stage, so it is forwarded from the execute stage of I1 to the decode stage of I2 from where? ALU1 or ALU2? ALU1. Any question? So please visualize it. And we filled all the tables. So now we filled all the tables. Is it clear or not clear? Clear or not clear? Okay, again. Now what I am going to do, so now please have a screenshot of this because I am going to rub this up. I am now going to rub this up. Because I will make small changes to the code. I will make small changes to the code so you need to know that what's going on. Okay, now what I'm going to do, so I'm going to rub this off. I have the same assumption now. I have now the same assumption. Okay, so what I'm going to do, so basically now this is my second assumption. So in this case now, are these two instructions dependent or independent? They are independent. So now I am now going to introduce another instruction. So let's assume we have an add and. Let's assume this is an add. And now this is actually R0 and then it depends on, let's assume R5. It depends on R5. So the one previously. R5 and let's assume this is R2. So we have now the red instruction. Now we have the black instruction I2.